Our first presenter is arriving from Portland, Oregon, to speak to us. And he's going to be telling us a lot of interesting things that I want you to take special notice of. He's going to be talking about cloud and the industry changing and the insatiable appetite of continuously evolving your business, but he's going to tell you how you can do that with Intel and the new technologies and the new architectures that they're developing. Kamhout is a senior principal engineer at the Intel Data Center Group. In his career at Intel, he has been one of the key leaders for software-defined infrastructure, STI engineering, and industry efforts. He brings many years of experience with him. Please give us a CloudFest welcome for Das Kamhout. Das. All yours, man.
Good morning. I was a little worried about presenting in the morning because I've heard rumors about this event, and apparently you guys get to sleep usually like 4 a.m. But I think today's good because the parties really don't start, except the Dutch party, till tonight, right? So you're all good? But 504 Dutch people. How many in this room are Dutch? Okay, so we're missing a lot of people. The party must have been epic. Okay, so I'm going to talk about cloud in general. And again, my name is Das Kamhout, Senior Principal Engineer. So I think the last talk was actually pretty interesting. We do clouds for basically lots of different reasons. It's not just about the technology. There's 4 major areas that, from an Intel perspective and across the world, we're super interested in pushing forward at an accelerated pace. The first is autonomous driving. How many would like to even ride on the Autobahn while sleeping in the back seat? I mean, I would. I mean, it's fun going fast, but being able to just let your car take the world for you, not just in your personal vehicles, but also in other types of transit. We're really seeing this move forward very quickly. Lots of investments in the space across the industry for autonomous driving. The second is artificial intelligence. Listening to the last talk, thinking about the humans and cybersecurity, things are going to get even more interesting at a very, very fast pace as artificial intelligence becomes more increasingly smart and starts taking on more and more activities across the world. As I'm sure you've all seen, Google recently won in AlphaGo, which is the most complicated strategic game. They did that in China recently. So the pace that we're seeing in AI is extremely fast, and it actually helps all of us day to day, letting computers help take care of tasks for us and do a lot of the things that we don't really need to do. The third that's growing also pretty fast, and not that many of us have it today, is virtual reality, as well as augmented reality. So seeing the world, whether it's something as like a factory worker, having augmented reality, being able to see their device, being able to see issues, being able to know how to repair it, all with a system on their face, is extremely interesting and will help us become more productive. And the last is in regards to how do we connect all these devices across the world, from cars to sensors in your house to your electrical systems, and that's through 5G connectivity. So Intel strongly looks at how are we changing the world for technology and how are we building things that basically support the path forward across at least these 4 key areas. Unfortunately, it's good to hear that this is now the cloud event. This is all built on a cloud. So pretty much every type of technology that's running today has some element that's running in a cloud or cloud-like environment. We're pretty familiar with the giant cloud providers. They're referred to as a monopoly in the previous discussion, but they're not really. There's 3 or 4 major large ones, but the world is basically going to require that we have many clouds of different sizes. Let's go back. So clouds of all different sizes across the globe. So even if you look inside of Europe, you'll see numerous cloud providers that are building out their infrastructure. We heard about China doing various things. If you look inside of China, you see 4 or 5. These are regionally specific environments, but they're also scaling out across their local area to increasing new environments. And when you look at either the giant clouds, hyperscale, or the smaller clouds, they all follow very similar technical components. So what I'm going to do next is walk you through a few of the examples of what the different types of infrastructure look like. So the first, I've been building clouds and large-scale infrastructures pretty much all my career, about 25 years. I'm 29, so I started really early in elementary school. But so if you look at the data center computing progression, the first is a traditional environment, and a lot of people have these today. A traditional environment consists of one app to one system. The little blue line is utilization. One goal that we have across most cloud environments infrastructure is driving your utilization up. You obviously, if you're buying a system or a storage or network, you want to make sure you're driving up your utilization as high as possible to achieve the lowest total cost of ownership. What we saw when we introduced virtualization to the world was the ability to pack more applications onto a single node. Applications use utilization at different times of the day, and what this led to is more sharing across a node, which increased the utilization of each node 20, 30%. In about 2006, Amazon created Elastic Cloud, EC2, and this was the first time we saw the ability for you'd basically able to go to a web page, swipe your credit card, and get access to a virtual machine instantaneously. The rest of the industry followed suit pretty quickly. We've seen things like OpenStack. We've seen things like VMware with the vRealize, Microsoft Azure, Google Compute Cloud, what One-on-One has, OVH. We have numerous situations where people are building orchestration on top of the infrastructure. What this has next allowed us to do was ease our ability to drive automation, make things more consistent, do things in a uniform fashion, and it also drove up the utilization. However, the fourth element is the hyperscale cloud. For the next slides, I'm going to be referring these to shorten down to Cloud A and Cloud B. But on Cloud B in the hyperscale space, basically, rather than thinking of a server or a virtual machine, you think of a process or an application, or specifically, what everybody knows now is containers, and the company that made containers really famous was Docker. Now, you don't have to use Docker, but that technology allows you to treat your data center in a brand new way. You can see your entire data center basically as one large computer, and these processes are being scheduled, kind of like a Tetris game, to pack up your data center so it drives up your utilization as high as possible. So this is where data centers are moving towards. It allows you to be highly efficient and highly optimized. And most scenarios when people have built these out, they're extremely, extremely efficient. But to be clear, based on our applications in the environment and the way people approach computing, all these models will persist for the foreseeable future. As we look at the progression of how these merge, if you look on the far left, you'll see the traditional infrastructure. What happened is traditional infrastructure, we first got what's called software-defined infrastructure. This is instead of buying a scale-up storage array network, you started switching to a scale-out distributed storage system. Rather than buying one server per app, you had a virtualized cluster that was scaled out that allowed you to cover your capacity. And on top of that, we put Cloud Type A, orchestration. In phase 3, which started happening pretty much heavily when Docker came out, was the DevOps, the software developers, realized, hey, I can use this container technology. It makes my software lifecycle much better. I'm able to write my code on my laptop. I can push it to a cloud. So this was really DevOps driven, but there's still probably 80 to 90% of all containers today actually run on top of a virtual machine. So it's still a model where they got the virtual machine and they ran the containers on top. And that's actually right now probably the major norm for anybody that's doing current software technology. They're utilizing containers on top of virtual machines. Phase 4 was an interesting idea. Nobody did it, so let's jump to Phase 5, because that became reality as we're seeing moving forward. Now, this is basically flip-flopped. Instead of seeing the virtual machines as the core, what's happened instead is the containers became the core. Containers have very interesting capabilities when they're orchestrated to allow you to basically run a high uptime, a highly efficient environment that basically allows you to run anything. An interesting thing that Google did, Google is one of the first people to actually do containers way before Docker, back in 2005-06. They actually exposed their virtual machines through containers. So just imagine basically your entire data center, it's all being scheduled with containers. If somebody launches a virtual machine from Google Compute Platform, it actually launches in a container and you get that VM. So underlying technology is all based off of containers and processes, and this is really the way moving forward. So if you look at an infrastructure solution stack, and I usually call this the simplified one, but it's also a little complicated. I'm not going to talk through all of it. But basically, every single infrastructure, whether it's container-based or hypervisor-based, looks like this. Fundamentally, you have your hardware, compute, storage, and network. Those are all moving at pretty fast paces in regards to evolution. Compute has been continuing to go very, very quickly with accelerators, with the introduction of new types of memory. Same as storage. We saw for many, many years people sticking to the scale-up model. The norm now is becoming distributed storage, which is highly resilient. We heard about the thought of in the cloud, if you have a copy and you lose that one, it's okay because you have more. Most clouds have at least 3 copies, and some have way more than that. So your Facebook photos are really, really safe. Don't worry about it. Next layer up is the hypervisor or the container. So regardless of which one you're using, that is a layer of virtualization. On top of this, which is key, is the orchestration and scheduling. I'll talk quickly about Kubernetes in a bit. Is one of the new container orchestrators that's running that cloud type B. On the far left, you have infrastructure management. So another thing that we heard earlier was how do we have the insights and the intelligence to see that data that's coming in and make decisions on it. It's not going to happen through humans. It's going to happen through advanced telemetry and analytics that's controlled by artificial intelligence. The amount of data and capacity that we're building and we're running just from humans alone is too much for a person to be able to analyze. As autonomous driving comes in, as virtual reality feeds come in, as AI expands, we basically need AI to analyze your infrastructure and make it more resilient. And then on top of that are all the apps and services that are being created across the globe. And these are apps and services that some of us don't even know because continually this entire space is evolving. So underneath all these stacks is basically a foundation. So if we focus first on the compute side, what we do see in the majority of the infrastructures is a foundation built on Xeon. We've been investing in Xeon for obviously many, many years. The x86 instruction set is the most common instruction set that we use across our software environments. And we're basically advancing every aspect from artificial intelligence all the way up to the APIs that run these. So just a few examples. On the cores, we continue to drive some of the highest performant cores that are available. The new technology with Xeon Scalable allows us to have a mesh network that allows each of those to have a very efficient way of communicating with each other. And if we look to the far right, Intel invests heavily in optimizations. So what I'll talk about in more depth is the amount of software and frameworks that go into powering all these complicated clouds and services is a pretty significant investment that makes sure that we're able to build off the hardware into frameworks and libraries that make sure that we're getting the most resilient and high-performance systems available to us. We obviously offer a very wide range of platforms too, from what we see as a very entry-level system But what is interesting, when you look at the largest public cloud service providers in the world, they actually focus on the systems that have the most cores. One of the reasons this happens is because through the software optimizations that they have and their ability to utilize the entire platform through things like containers and optimizations, they're basically able to use the entire platform. When you use the entire platform, you want more platform in each node and the ability to maximize out your capacity. So driving things heavily to more cores, more sockets, increasing memory bandwidth, and increasing the amount of memory itself that you can deal with. For instance, with upcoming technologies such as 3D Crosspoint, which gives you almost DRAM performance at way lower price. So I'm going to switch to talk mostly about our software optimizations. So I'm not sure how familiar you are with how Intel invests in the software community. These are just some of the examples. I'm going to focus mostly on the operating systems and the data center and cloud. But if you're working in the IoT space, if you're working in the development space, Intel's a heavy investor in making sure that these environments are, again, highly performant. We even focus on ease of use, but things to make it easier to push technology in the industry forward. One of the examples is on the Linux kernel. So I actually remember, as I said, I'm 29, and I started working 25 years ago. But that's around the same time Linux was around. And Linux was a massive change to the industry. How many of you remember Unix? Anybody Unix? OK. How many of you used Linux? OK, a lot of you. So interesting thing with Unix was it was only for a special few. It was in universities. It was in environments where people can afford extremely expensive nodes. And it wasn't really available for the masses in order to build systems and to create new software. Linux really changed the world. Every single large-scale cloud provider has Linux in their environment heavily. Even Microsoft, who's obviously a Windows shop. Their move to open source for the Linux kernel has been a game changer in our ability to create new innovation in the world. And one interesting thing to point out, if you look at all the companies that invest in Linux, Intel has the largest contribution by percentage out of anyone, even Red Hat. And Red Hat's one of our key upstream Linux partners. So the key is our investments is designed to help push the industry forward with tech. Has anybody out here used OpenStack? There's a couple of you. OK, so I recall when OpenStack first came out, actually my team, I used to work inside of Intel IT. We built it out on the 4th release. It's called Diablo. Everybody told us we were crazy. But we also then decided inside of Intel to invest in the technology, invest in the open APIs, invest in the system. And now what we see today is OpenStack across many, many, many environments, from cloud service providers to comms providers and into enterprise. It was kind of a game changer to drive innovation, to allow people to create open APIs to run infrastructure. So we continue to invest in this space as the foundation board. In the working groups, we help prioritize the work. If any of you are large OpenStack users, we're always interested in talking to you to help drive the development community forward. And we're heavily involved in tech leadership from code talks, project technical leads, but making sure that this code base as well is moving forward, powering clouds. And then the last one is on Cloud Native Computing Foundation. I talked about Kubernetes. This is one of the third technologies that I think is really changing the world. Kubernetes is basically being equated to the new Linux, but how we deal with containers and how we run applications. Just some quick examples. Vitess, a very, very interesting part of the CNCF. This is how YouTube runs MySQL. We're in a movement today where people that run large-scale infrastructure are sharing their code publicly. This is a very good thing. It's usually open code and allows each of you to be able to grab that code and run it in your environment. Prometheus is another example. CNI for the container network interface is another example. The movement that we're seeing with the CNCF, which was founded by Google and Intel, is really changing how we do cloud, and it's technology that we're making sure is available to everybody so you can push technology forward. OK, I'm going to talk about one of the four of the areas I discussed, artificial intelligence. A lot of people don't equate Intel at the moment to AI, but in reality, lots of AI actually is running on Intel. Some very large CSPs, cloud service providers, have said they run all their, with excess cycles that they have, they're running deep learning inference on top of Xeon nodes. But I'm going to focus more on training. If you're familiar with AI and deep learning, there's two elements. There's training and there's inference. Training is like, I have a bunch of images of cats, and I want to make sure that you know that this model is all cats. And then inference is actually looking through all that data and finding the cats. So on the training, which is one of the hardest things to do, basically in this situation, these are all real-world situations. I have drones flying over a solar array, a solar farm, and it's able to basically analyze and detect problems in the environment. So in this scenario, with one CPU node, it took 6 hours to train with Intel Caffe, which is a very common framework, how to do that. In another model, we have basically creating silicon is very, very complicated. In this scenario, we were able to do fault detection using deep learning on 8 CPU nodes, so moving from 1 to 8 in this situation in 1 hour. But what I want to talk about is basically scaling, and this is one of the interesting aspects of Xeon with deep learning. In this situation, and this is using ResNet. ResNet's a very, very common topology. This is using capability. I talked about the libraries. This is the machine learning scaling library from Intel. But this allowed us to basically scale linearly with zero loss across 64 nodes to achieve a pretty high 5,000 images a second. So point being, one CPU, 8 CPUs, then running across 64 nodes to achieve throughput scaling. And we took this even further. We like to keep scaling and scaling. And we found with ResNet 50, with 256 nodes, we can also achieve almost a 90% scaling efficiency. And last, we did some work very recently with UC Berkeley, again with ResNet, time to train, and across 1,600 nodes, achieving a 31-minute time to train. Now, this is compelling because a lot of people already have Xeon in their environments today. So rather than bringing in a whole new infrastructure, this allows you to use your existing assets to be able to conduct the training work with frameworks that exist that are normal, such as TensorFlow and Caffe and MXNet, in order to get your deep learning going. So if you're investing in AI, realize that we've been investing for quite some time. OK, before I bring in a guest to do a quick walk-on and talk about how they're doing some of this tech, I want to quickly just remind you back to the cloud service progression and talk about one key element. We had bare metal hardware, which was the traditional environment. We then moved to virtual machines, which gave us infrastructure as a service. And then we had containers and platform as a service. And there's a new model coming called function as a service. Some people call it serverless computing, but there's a heck of a lot of servers underneath there. So we like the word function. And this is becoming very, very common in concepts like IoT. Now, to talk about some of the container work, I'd like to invite up one of my friends and one of our key partners, Rainer. He's the Vice President of Data Center Infrastructure at 101. Hey, welcome, Rainer.
Good morning.
How are you?
Hello. Thank you, Dos.
So you guys have been doing some container work.
Yeah, sure, for some time now. Before I like to start talking about a little bit about the machine room, let me spend a couple of seconds on the beautiness of container as a service. First of all, the existing container platform we have can leverage the entire shared hosting ecosystem. So we not start as an isolated CaaS platform. All the monitoring, backup functionality, all the domain, SSL, DNS, DDoS protection, web application firewall. So all the surrounding ecosystem is right there in the beginning and contributes to the entire Docker and CaaS ecosystem. We use this platform internally since a long, long time, the Docker platform, to support the fast-growing number of apps from WordPress, Drupal, and all the development stacks, all the variants of development stacks. They're all running on this Docker Kubernetes platform to allow the scaling that is required in this large infrastructure. If we ask our customers, most of them don't want to manage the infrastructure, the platform themselves. They want to have the option to do this when they need to, but most of them really want us to update the platform, to do all the patching, to operate the infrastructure. And that's a model which is quite common in industry right now, and that's what's followed by this platform as well. In combination with the seamless transfer of data, there shouldn't be any vendor login anymore. We should make sure that all the hosting industry commits on a standard allowing to seamlessly transfer any data, any application to any partner, to any supplier, even on their internal and local laptop. Now, to achieve all this, we need really significant technology. We need really to work closely together to get a good price point, a fair price point. And we worked a long time together with Intel in figuring out how this can work. And looking a bit in the machine room, the first platform which was available to allow us to scale to this extent was the Intel Xeon Scalable platform. Because we can reach this density that is required to offer, first of all, fair price points, to have a reasonable total cost of ownership, and to cope with all the east-west traffic. Most hosting providers haven't seen this east-west traffic in the past. It was more north-south. But if you have this more modularized Docker infrastructure and Docker containers, if you program software cloud native, you have a significant increase in east-west traffic. Having these containers running on the same node gives you tremendous performance. But to allow so many containers running on the same node, you need the right node. And the Intel Xeon SP gives us really tremendous performance increase to operate this platform. Now, what you need in addition is you need very, very clever architecture and very clever software to manage the location of the containers. And here, artificial intelligence will help us really to make sure that the system itself, the nodes, running at the optimum performance, that we make sure that we leverage as good as possible from the existing infrastructure, at the same time offer the maximum performance and service level to our customers. Now, to make all this possible and to have it as a very easy ecosystem, we need to work closely together with all the partners, and Intel was one of them. And I think we showed just on the last weekend that this can be very successful.
Exactly. So one, I think it's great you guys are using a lot of the tech we're talking about, containers, Kubernetes, AI, and you're really driving the network bandwidth. And then what we did is we actually, on top of that, we had a recent hackathon, and this was to basically take one of the use cases around IoT. And IoT, we have this open IoT service platform, which is open source technology, but actually running on one-on-one with Kubernetes, we're actually able to prove out with the developers this week, and I think there's going to be some results later about how this all connects together. So IoT devices, hitting the back end, launching container orchestrated solutions, and it's actually all real. At least the screenshots are real. We've been told these really do exist. But basically having a device that's secure, calling into the back end, and we've been proving it out with one-on-one. So it's pretty awesome to have you guys working with us on this.
Thank you.
So it's all about connecting these use cases of where we're pushing the world with key partners like Rainer and what they're doing at one-on-one with the key tech that's required in order to make many of these clouds. And we're inviting you all who are part of this journey to get involved. We have a thing called the Cloud Insider program. It's the ability to come in. Intel has a suite of engineers from the hardware all the way up through the stack to APIs that are interested in helping you push your company forward and push the industry forward. We have opportunity for you to test drive any new hardware through our Cloud Insider sandbox, and really work with you on even go-to-market to help you make the world know about your capabilities, let the world see the disruptions that you're creating so that we can basically push tech forward. So what I'd like to do is have you all realize we're in this hyper-evolution. So what we're trying to do with artificial intelligence, with autonomous driving, this is a game changer for how we have new apps and services that are going to change how we as humans operate in the world. Together with our hardware and software investments, we're basically driving the tech forward. So it's not just Intel alone. We have a team of partners, including many of you, that are working together to drive the industry forward. It's the hardware and their software that make this real to power these new use cases. And what I'd like to see is us partnering together to make this all the new normal. So thank you all very much for your time, and hope you enjoy all the amazing festivities to come.